Section 7.4, solving logarithmic equations. As a refresher, a logarithm is when we have something like b to the y equals x. We can rewrite it as log base b. In both of these, b is the base because it's what the exponent's attached to. It's the base here because it's at the bottom of that log. So log base b of x equals whatever's in that exponent. Okay. Conversely, b to the y power equals whatever is inside the parentheses on that log. In this section, we're going to be solving logarithmic equations like this one here. Log base 2 of x squared minus 4 equals log base 2 of 3x. Now, when we have the same log on both sides, right, we're taking the log of some number, and it's equal to the same log, okay, taking the log of another number. Okay, if these are going to be equal to one another, these two boxes have to be the same. Okay, that's the only way we're going to get the same thing on both sides. So we can just set up an equation, x squared minus 4 equals 3x, move everything to one side, and at this point we have a trinomial. We can factor it by earmuffs, and we get x minus 4, x plus 1. I'm skipping all the factoring work. If you're confused on how we got these two parentheses, you can go back to chapter 4 and find that video on factoring. Okay, once we get those two parentheses, we get our solutions, x equals 4, x equals negative 1. We get those by just setting each of these parentheses equal to 0 and solving. Okay, now we're not quite finished because for all of our logarithm equations, we want to plug it back in and make sure it works. So if we plug in a 4, okay, we have log squared of, or log base 2 of 4 squared minus 4, so that's 12. And on the right, we have 12 again. Okay, so this one works, that looks good. Okay, if we plug in a negative 1, over here we're going to get a negative 3. Okay, this is not allowed. So we get the same thing on both sides, but we're not allowed to take a log of a negative number. If you put this into your calculator, it's going to give you a domain error. So this answer we throw out. It's an extraneous solution. So notice the difference in this equation. Here on the left, we have a log base 4, but there's no log base 4 over here. Okay, and the last one we did, we had logs on both sides. So we can't just take this and set it equal to the 2 for this problem. And instead, we want to rewrite it using those same rules that we did in the previous section. So 4 to the second power is going to equal what's on the inside. Okay, x squared minus 6x equals 4 squared. Now this we can move all to one side and then earmuff. X minus 8, x plus 2. We get 8 and negative 2. If we plug those both in, we want to see, do they equal 2? So 8 squared minus 6 times 8, 64 minus 48. That's going to give us 16. Over here we have negative 2 squared, that's 4. Negative times a negative plus 12, that's also 16. So these are both the same thing. Neither of these is going to be extraneous. 4 squared equals 16. We've just verified our answer. Both of these are correct. Number 3, we're back to having logs on both sides, which is going to make this at least a little easier compared to the last one. So 2x plus 1 is less than or equal to x plus 4. Okay, subtract the x, subtract the 1. We get x is less than or equal to 3. Now keep in mind, we can only go so far to the left. Like for example, if we were to plug in negative 10. Okay, negative 10 is less than 3. But if we put in a negative 10 over here, this is going to equal a negative 6. We can't take the log of a negative 6. So at some point, we're going to have to stop because we start to get negative values, and we can't take a log of negative values. So we want to figure out where that is. Okay, so what's the smallest this can be, right, where it's staying positive, okay, or not negative at least. So we want to set it to 0 or above. Okay, so we set it greater than or equal to 0, we solve it out, and we get x is greater than or equal to negative 1/2. We're going to do the same thing with this one. We get x plus 4 is greater than or equal to 0, so x is greater than or equal to negative 4. Now we have 3 things here, and we want to see what's our actual set of solutions. Okay, so if we did a number line with all these, we have greater than or equal to negative 4, greater than or equal to negative 1/2, less than or equal to 3. The place where they all overlap is this section right here, between negative 1/2 and 3. That's going to be our answer.